Hello, welcome to the video on solving exponential equations. This is our fourth example set D, and I hope you had a chance to watch a lesson and practice the previous example sets. And once again, we're going to be looking at a word problem where we're going to have to solve an exponential equation. Okay, I actually think these are pretty fun, but that's just me. So let's read the problem. Okay, uranium decay. So uranium is this radioactive isotope, if I'm not mistaken. It's a radioactive material, and it decays over a period of time, i.e. dwindles away. Okay, so that's what that means. But you have this material, uranium, that's dwindling away. So we have uranium decay can be modeled by this particular formula right here. Okay, and you can clearly see it involves an exponential function. So the question is, how long will it take 50 grams of uranium to decay, dwindle down to 25 grams? So we're starting with 50 grams. How long is it going to be reduced by 1/2 of its original size? And we call that the half-life. Okay, so i.e., what is the half-life of uranium? Okay, when we're talking about 50 grams. All right, so to set this problem up, it's actually pretty straightforward. The formula says let's start this way. Uranium, is the amount of uranium after decay, because that's the amount we are going to end up with after so many years of decay. Of course, in this problem, that will be 25. Okay. U naught, all right, this is our initial amount, and our initial amount here, U naught, is what? It's 50 grams. And then, of course, T is the number of years in decay. So let's go ahead and set that up. If you haven't tried this problem, I would suggest you pause the video and plug in the values as you see them. All right, so we have 25, okay, is U. We start off with 50 grams. Okay, 25 grams is what we end up with. We start off with 50 grams. E to the negative 0.00039 T. Okay, let me erase this here so we don't have any confusion. All right, so the question is asking how long will it take? So how many years? Okay, that's half-life. So you can see the unknown quantity in this problem is T. So we have to solve for T. We have a basic exponential equation, and everyone by now, hopefully, is comfortable with solving these exponential equations. If you're not, you got to go back and take a look at the lesson and practice that procedure in other problems we've done. Okay, the first thing I need to do is isolate the power portion of the equation. And that's this portion right here. So I got to get rid of this 50. Divide both sides of the equation by 50. And what we're going to get is 0.5. That's just 1/2, or 0.5. I'm going to express it as a decimal. Equals e to the negative 0.00039 t. Okay. Now we're talking about base E, so instead of taking a log of both sides, I'm going to take the what of both sides. You're going to take the ln of both sides, and I'm going to go this way, ln E. I'm just going to reverse sides. I always like to have my variables on the left, so I'm going to write this on this side, ln negative 0.00039 t equals ln of 0.5. All right. Once I've done that, of course, I could drop down this power. Let's actually take this whole problem, move down here a bit. Okay. All right, so once I've done that, I can drop down this exponent, in the power, using that power property of logarithms. And this is going to be negative 0.00039 t ln E equals ln 0.5. All right. Now what? All right. Basically, we should know now, or you should have screamed it out to me and said, oh, ln E is equal to 1. Get rid of it. And that's exactly right. ln E is equal to 1, so it basically just goes away. So our equation distills down to negative 0.00039 0.0039t equals ln 0.5. And of course, to solve for t, I simply just need to divide both sides of the equation by negative 0.00039. And this is going to be negative 0.00039 over here. And by the way, notice, I'm doing a lot of writing here and taking my time. Does it get a little tedious? Of course it does. Can you make a mistake if you rush? Of course you can. But discipline and creating good habits, that's a big part of math. So take your time and learn to be patient with these problems. These problems just don't happen in a snap. And more often than not, the mistakes you make will be because you kind of rushing the problem. So if I'm going too quick, sometimes I like to slow things down. All right, so we divided both sides of the equation by this negative 0.00039. And what we need to do now is plug this into our calculator, and we will have solved for t. All right, so we'll just take a moment and do that. Okay, so t, I'm getting 1777.3, and that is what? Okay, that's time in years. So we're talking 1,777 years for 50 grams, okay, to dwindle down to 25 grams, okay, and this is, of course, uranium. That's the half-life, right? This is the half-life of uranium. So, once again, straightforward process. The word problems are more often, some of these formulas are, pretty straightforward. So you'll see a ton of these type of situations in, science class, especially, high school and beyond. Of course, definitely in college level science classes where you're, expected to know some, pretty sophisticated mathematics. But here you can see, once you know how to solve these exponential equations, they come in handy all over the place. All right, so uranium decay. Of course, we won't be around to see it. 1,777 years, pretty long, but that is the half-life. Okay, keep working hard. Good luck.